All right. Looks like we're just about ready to go. Is that correct, people? Yep. Awesome. So welcome everybody. Welcome everybody virtually and in person. We have Tom Nichols today, who really needs no introduction, but I'd love if you could give just a few sentences about yourself and what you do. We're just going to have kind of in just a minute, we're going to have an informal conversation with Tom. I'll be fielding questions from the virtual audience and people who are there in person. Please feel free to come up to the podium and ask your questions. But first, yeah, Tom, if you don't mind giving kind of a short introduction.
Sure. Yeah. So I'm Tom Nichols. I'm a statistician. I trained I got my undergraduate degree in mathematics and statistics, and then actually didn't really know what I wanted to do, and just kind of lounged around for a summer, and actually thought I'd be a photographer, and then that didn't really pay very well, and then just had a random email from a professor who said, "Oh, they need a person to do something at the hospital with images." It's like, okay, I do JPEG, GIF, and like, well, it's more like PET, MRI. And yeah, I was very lucky to just land in a really excellent imaging center led by Mark Minton, who had recently done sort of foundational work on blood flow with Peter Fox, and some really expert people in both PET and MRI physics. So they had Paul Kinahan and David Townsend, who were doing what was at the time the cutting edge 3D image reconstruction for PET, and then of course Doug Knoll in MRI doing important work with bold physiology. So I came in as an application programmer, but saw that and just learned an incredible amount, and it was an incredible place to be. But knew that I needed more training, so then I sort of slowly made my way back to Carnegie Mellon, where then I did my PhD in statistics in PET. And then when I finished that, I went to the University of Michigan in biostatistics, and mainly did MRI going from there. And so I was at University of Michigan Biostatistics for 6 years before getting recruited to GlaxoSmithKline's Clinical Imaging Center. Never really thought I'd ever go into industry, but it was a confluence of both personal situation, my wife being German and wanting to be able to move to England, and then the interest of sort of learning about clinical trials, and of course made easier by the fact that I already had collaborators in England, and so with between people in Queen Square and in Oxford. I was there for 3 years and then left, fortunately, just before GlaxoSmithKline basically got out of neuroscience and closed the center. It wasn't my fault. I went to the University of Warwick, where I joined the statistics department there, which is a really excellent stats department. But there's no imaging there. But maintained that work through collaborations, and then had the good fortune to be recruited to the University of Oxford, 2016, I think, when they opened the Big Data Institute, and that's an institute focused on sort of doing population scale studies, most represented by the UK Biobank. But so I continued to work on PET and MRI modeling, but with a focus to large scale studies. How's that, Stephanie?
That's fantastic. Actually, I especially appreciate the origin story. I think it's really nice to hear when people came into the field, without necessarily a clear idea that they wanted to do MR, um, and hearing just about your evolution, especially as someone who's been really influential in how we understand fMRI statistics, is really nice for me to hear as well. Um, so along those lines, just to get things started, I'm curious to hear when you first you had been a photographer and you first entered a lab doing PET, did you have any sorts of preconceived notions of what, you know, different types of biomedical imaging could mean or their translational potential while you were first in kind of that early training stage and familiarizing yourself? And I'm curious to hear how that has changed over the years.
Hmm. Well, I mean, PET aspires to be a quantitative modality. We often don't make that fully quantitative, but that's the goal. So, um, although actually, sort of as a just anecdote, I think I did all right in college, but the two of the subjects I hated were physics and biology, and I just kind of slouched through them, and then come to a PET center where the most important things are the high energy physics about counting photons and the biology of how these tracers move through your physiology. Um, so that was clear that stuff was important, and I wasn't obviously leading that. I was just supporting that, but that it was very enjoyable. I mean, I think I knew right away that it was going to be more than a job, and that I was really going to try to get back to grad school. When my job was helping people with statistics to do their analyses, but conversely, these are sort of top brain imaging neuroscientists, psychiatrists who are trying to understand the brain. In the process of me helping them, they taught me about the brain, and that was amazing. That was great, right? And that really sort of energized me. And to take it, I basically treated it like a grad school, even though it was just a job. While some of my peers would go off and like buy cars and like get a fancy apartment, I was like, no, okay, I'm gonna get a house with a bunch of other people, and I'm in for the long haul.
Excellent. I'm going to keep asking questions selfishly until someone comes up and interrupts me or I see one pop up because I've been wanting to pick your brain for a while. Um, so I'm curious to follow up with that earlier question and your response. Would you say that you become more or less optimistic about the potential for especially MRI and fMRI for translation throughout the years?
Yeah, so I mean, I think I'm always, I mean, so I'm very optimistic about what we can do with imaging, but focusing specifically on the translation, it's a continual challenge, and I think we need to focus on it. I think we all do really interesting, exciting things here, but if you're asking, like, what if you removed imaging from the picture? Like, how would we treat patients differently? And it's not. I think a lot of times, we have yet to show that imaging can really, make a difference translationally. I mean, I'm happy to say I work a lot with multiple sclerosis, and that is, I would say, the neurological disease which sort of really most depends on MRI for routine tracking of the disease, and it's not, it's not just academic. For example, when my mother first had a stroke and then was getting ill, and then we're like, oh gosh, is this just you have AD or vascular dementia? The doctor said, well, we're not going to do another scan. That would be academic because it's not going to change the way they treated her. Whereas, of course, obviously we do MRIs all the time to try to understand how the brain changes in AD, but it's not necessarily changing the way patients are treated yet. So am I optimistic? Yes, of course I'm optimistic. I mean, I think there's great potential, but I think we have to focus on that as a goal.
Yeah, absolutely. I guess when I bring up the question of potential, when we talk about crises in the field, it often has to do with, potential for psychiatric illness and for understanding, more complex behavior. And sometimes we don't bring into the conversation, neurological illness for which there is clear, you know, proven and ongoing application for bioimaging. We focus a lot on like these more complex problems that have a lot of the hype in our immediate kind of subfield and that we see brought to the forefront at AOHBM. But you're right, there's, so much application that's already ongoing. Um, so
Stephanie,
I'm curious. Oh, yes.
Is there a
I'm just
question
going
from
to
the?
interrupt you really quick because a bunch of people just came in. So for in-person attendees, if you have a question, just walk on up to
I
the
would love to have
podium.
someone from the audience ask
And
something.
because we want to make sure the virtual attendees here. But no need to raise hands, just go right up. Okay, you can continue.
You can also raise your hand and then just say it, and I'll repeat it if you're shy. Nothing yet,
And
Stephanie, so you
for,
can continue.
oh, yeah, of course. And I'll just recap for people who just entered. I think one of the most interesting tidbits I learned today was Tom was originally a photographer. He wasn't necessarily interested in specifically biology, physics, but ended up joining a pet lab um, just out of I guess out of an interest of learning more about that particular modality. Is that correct?
I needed a job. That's all.
Out of
I,
interest in making money,
yeah.
but sort of a non-traditional path in that direction, starting from more of a, what was your interest in photography more on the technical side or sort of more on the artistic side?
It's actually a family thing. My grandfather ran a camera store. We always had cameras around, and my brother owns a camera store now. So it's always like kind of in my blood, and frankly, is also being as someone who's kind of shy and socially awkward. You might not know that. I mean, the camera was a way in social gatherings to kind of like, open things up and take pictures and, get in people's faces. And I kind of like that. It's kind of a crutch for me. But now there's nothing special about cameras. Everyone has one.
Yeah, to honor the days when you go to the dark room and you have
Yeah.
to do all this special kind of chemistry and experimentation to develop.
Although, actually, one thing I miss is that I did, even into the days when people had, digital cameras, I had a large format 4x5 camera and a Polaroid back for it. And if Polaroid was still existing, I mean, Polaroid ran out of business, but I would still do that at parties. That was so much fun to actually get like a big real life picture at the time, but Polaroid, it's gone. You can get the film, but it's super, super expensive. Question in
My,
the room.
oh,
Alamea.
great.
Yeah, come on, take a seat.
Sorry, I was triggered by the earlier remark about the lack of clinical application of imaging. And, this was going to be about open science and open source, I guess, in the case when you're a methods developer. What I often find strange is that, we love to make methods, we do loads of stuff, and a lot of that doesn't make it to the clinic either. Do you think that has to do also with the fact, maybe that imaging is not accepted into the clinic, maybe, but also that with the fact that many neurological diseases are not really treatable, are not really reversible.
I think it's a combination, but I think it's also that it just takes a lot of work to get something into the clinic. So I'm in Oxford, and the FSL group is working to make their tools more useful to clinical people. And there's actually a project where they're actually getting people who are referred to the memory clinic who wouldn't normally get a scan to actually get a suite of MRI scanning, with the goal to see like can this make a difference. But when we do things, it's really easy to show population differences, but to actually do something for one individual, it's hard. So I think it's just a hard problem, and it requires a lot of validation to actually show, that you're going to make a difference. So
Yeah.
I think it's just a hard problem.
Yeah, it is, but there's also the difference, or maybe, I don't know, between commercial tools and tools from our community. I don't. Yeah, I'm a bit biased, but I don't necessarily think that commercial tools do a better job at, for example, detecting MS.
Yeah.
But yet the software that we make has a very hard time of reaching it to the clinic, and I wonder if there's a way to solve that.
Well, I see it as, it's the difference between like making an academic product and a commercial product. Because if you're making a commercial product, it should work, 99% of the time or 99.9% of the time. But as an academic project, it may like only work 80 or 90% of the time. And as Fidel well knows, when something doesn't work like 20% of the time and you have 40,000 scans, that's a big problem. And so I think what holds us back is that final, whatever 5% is kind of engineering. It may not be the most interesting, work to get those final edge cases to work, but it's what you need if you want something that's going to be reliable and used in practice in a clinic.
Yeah, that makes a lot of sense. Thank you.
Okay, another question? Christian Gazer.
Yeah, my question is a bit related to that, what we talked about that in the previous question. So we see a lot of commercial applications which are finally based on open source tools. So the GPL explicitly allows that, but I also often see that it's not even mentioned on which tools these commercial applications are based on. So I would be interested in your opinion about that. And me as software developer, I'll also like to see the tools distributed, but on the other hand, it's also somewhat difficult to deal with that. It's not even mentioned. And also, is there any way to deal with that? And I don't want to just Yeah, it's just a mix. There
It's a
are
tough thing.
ideas of having multiple licenses for tools, for example, or something like that. So I would be just interested about your opinion
Yeah,
on
I
that.
mean, so I can start with FSL actually has a non-commercial use, or if you want to use FSL for a clinical trial, or frankly to like make some money on the side doing consulting for someone, that's technically you need to have a license with OUI, the Oxford
Yeah,
Innovation.
same as for FreeServer. But what about tools which are already on GPL?
Yeah, I mean, I wish they would credit them. I don't know what the solution is. I mean, because you think about it, I mean, any tool you deal probably is going to depend on just a huge swath of libraries, and how do you sort of appropriately give credit to that? I mean, do you have a big long scroll? You know, every time you fire up the program, I don't know what the answer is. I mean, I always thought it as the open software sort of vibe is you just throw it out there and hope it gets used. And I think if that's not good, or if that's not how you want it to be, I think then maybe the non-commercial is the right way to go. So if someone does make money off your stuff, that you need to be compensated. So I mean, it's not. So I don't think there's any good answers to what you want.
Yeah, that's what I've expected, unfortunately.
Yeah. What software is it when you open it up? It like shows you like a different credit each time. I can't think what I'm thinking of right now. If there's some program that when you open up, it will give you some,
I have never seen that, and probably you have also noticed there are a lot of tools for neuroradiology which are labeled with this AI, which is finally just based on normative modeling, and so it's
well,
it's
AI is
questionable.
mostly logistic regression.
But I have never seen it. I've just seen some solutions where I could just dig into the code and found that they use a bunch of different GPL tools without mentioning that.
Yeah, I think it's just too much. I mean, to credit. I mean, think about the open the libraries and the low level blasts and all that stuff.
Thanks.
Absolutely. I think AFNI does cycles through the photos of contributors, and you're able to just upload your own photo.
Oh, I think it's my Garmin sat nav that shows a different sort of copyright notice every time I fire it up. Got another question from the audience? What's your name?
Hi, my name is Laura. Thank you for being here and answering all our questions. I was just wondering, because we were talking about translation to the clinic, what you think that are some key points for us to keep in mind. I was just thinking about things like how it would need to generalize to also minorities, for example, and bias that could be in deep learning tools, but also the issues with side effects. And I was just thinking about do you have any thoughts about that and how we should address this?
Well, you just mentioned some of the trickiest aspects, and I should say, I don't really do much with translation myself, but yeah, I mean, paying attention to bias and generalizability is essential. What else? Yes, side effects. It's got to work on all sorts of scanners and locations. Yeah, I mean, I think what you mentioned. I'm trying to think if there's any other things. And I mean, it's also, of course, it's got to be able to be scalable. And I guess the other thing too is it's got to be interpretable. So when a doctor makes a clinical decision, I think it's not very useful. It's just like yes, no, or like you have 2 years to live. I mean, you need to see where did that decision arise from, what went into it, and that's, I think, another challenge, especially for deep models.
And would you have any thoughts on strategies for us as a community to tackle these key points?
Not really. I mean, just paying attention to them. I mean, building models. There's a lot of. I'm just in the poster hall, and there are ones that working on deep models that pay attention to covariates to make sure that the latent representations are invariant with respect to whatever site, age, gender. So it's just a central challenge you have to pick up with any kind of methodological development you're doing.
All right. Yeah. Thanks.
Anything else from online?
I'm not seeing anything online, although we do have
we have another
quite a rich audience.
We have another person in person.
Hi, I'm Joram. So when reading your CV, it says that you have industrial and academic experience. I want to ask, first of all, where did you work in the industry, and would you say that having industrial experience helps in your academic work in some way?
So I worked at the GlaxoSmithKline Clinical Imaging Center. It was a purpose-built center built in London to do PET and MRI imaging. The idea was that traditionally companies depend on academic partners to do a lot of the scanning, and they thought, okay, we can speed things up if we do it internally. I don't think it worked out that way. I don't think it was any faster or more efficient to do it internally. My favorite little sub-detail is that when we actually ran studies, it turns out GSK never ever touches humans, like directly interacts with them, because he always used a contract research organization to actually do the recruitment and do all the governance associated with that. So we had to hire a CRO to do a study in our own building because it just didn't have that in-house expertise. Anyway, so I learned a lot about clinical trials. That's the thing I learned a lot, the most of, and I think also learned the importance of well, I should say, when I got there, I was actually really impressed. I thought like, it's all going to be sloppy, just going to get the money, And in fact, it was some, everyone was really outstanding scientists and really thought critically about the data. They have money, but they have lots of choices, and they were always trying to use the evidence, in the best way possible to decide, should we spend our money on this compound or this compound, or what's the next best study? And it was very evidence-based, and that part impressed me. But ultimately, it is... you're in a company. I was in a company with like 100,000 people, and so you don't have a lot of direct control over the direction what you're doing. So that's ultimately why I went back to academia, is because I wanted to have that control over my career. And in academia, we survive or fail on our ideas and the ability to get funding. So yeah, there's that. And the only other thing I would say is a lot of people ask me about going into industry in terms of career direction and stuff. And I will say that if you go in at a very junior level, I'll just say it's very difficult to come back, I would say, right? Because the currency of academia is papers. And while that is something that people in the industry do write papers, it's not the top priority, and you will not produce things. And oftentimes they take very long things. And actually, the most exciting things, if they have an exciting compound, that's the stuff they'll wait the longest to publish on, because of course they want to keep it proprietary. And it's kind of the things that didn't work that maybe were easier to publish. So as a senior person, I was fortunate. I already had a CV, and I had stuff coming through the pipeline when I was there. So it even looked like I was productive, even though those were like papers that I finished at Michigan. They're still ongoing at Michigan. So if you're a junior person, you're kind of like trying to, in the balance, should I do a postdoc, should I do industry? I would just put a little bit weight on the academic side, because it'd be difficult. If you change your mind, it can be difficult to come back. Not impossible, but just difficult.
Okay, thanks. And maybe a follow-up question, since this is called your role in open science, now that offerers of commercial products or industry companies are moving a little bit into open science and, open source, as someone previously also said. Do you think this is really compatible with their business model, or is this just making some good words in order to keep people using the proprietary products?
I may be naive, but there's companies like Red Hat, which are based on open source software, but exist to basically service and provide something that's slightly more reliable and supported. So I think there's definitely a venue to basically make money in the context of open science. But hopefully you are then giving back, and I think that is the case with Red Hat. Someone probably knows more, can tell me I'm wrong on that, but I think it's possible. We have another question from the audience.
Thanks. My name is Victor. One thing that we are facing quite a lot of trouble is about opening the data, which is kind of a key thing in the reproducibility of all of the studies and so on. Because of course, the GDPR comes with a very good will on protecting identities and so on, but at the same time, like the regulatory bodies and so on, they kind of see it very differently, and they do not adapt everything to the academic context and to the commercial context, which should be the most protective one. So my question is basically, we are now having a lot of problem in opening the data that we have because of these legal issues on opening personal data. Did you face these problems somehow? How did you handle? Do you have any good argument to these kind of things or workarounds? Because the data is personal, whatever it is.
Yeah. Yeah, it's funny. I think if you're asking me, like, or am I optimistic about the field in general? It's like, yes, I think it's great things. But if there's anything I'm most worried about is information governance. And I think it is the thing that could derail so much of our efforts in open science. And it is a huge headache. In Oxford, we're trying to create an open repository. And honestly, I feel like it's almost it's hard enough to get the lawyers and stuff, in line and trying to help us with that. But then, like, you wait a year and then it's different. Like, the regulations have changed, they're more stringent. I'm involved in a project with Novartis, and before they send us their data, they actually send it to a Privacy Analytics in Canada. It's like a firm that exists just to do anonymization, and they basically delete variables and coarsen things, like they replace ages with age range to meet some sort of industry-agreed standard on de-identification. And it's incredibly frustrating as a scientist to be like, you're going to mess up age? It's like the most important thing. How can you do it? It's like, well, we can not mess up age, but then we'll have to delete other variables to make sure that it's sufficiently anonymized. So it's serious stuff. I don't have the answers, but it really kind of scares me.
Yeah, but do you think that there would be kind of because the way we've been handling it now is like moving backwards, that we started to open things and then suddenly we have to kind of protect more stuff. Would there be then, do you think that it is optimistic that we are going to be able to actually deal this, even if it's just for the academic purpose?
I hope so. I mean, I definitely understand and respect it. I mean, like, I don't want my data, messed around with. So, I mean, I understand why we're doing it, but it's just we all have to prepare. Like, it was like 5-10 years ago, I'd say, okay, everyone needs to understand that they need to add someone, data management staffing to their grants. Like, you need to have someone who's going to manage and deal with all the just moving the data around and organizing its story. And now I feel like, okay, now every project needs a data governance person who's going to deal with the legal aspects, of the data protection. And I think we just have to accept it as a new normal. Like, we have to just be ready for that stuff. And I'm talking to Franco Pistelli about actually trying to develop international standards for data sharing, because right now, kind of like every institution, every person who's trying to do this is going at it themselves, and so we're trying to see, can we do something better? Can we make something that people can reach towards, at least as a starting point?
Oh, thank you very much.
Another question from here. Tibor, Hauer?
Hello, my name is Tibor, and I have two questions, if that's all right. One is, how do you see that reproducibility is perceived in academia versus in industry, both in terms of severity and also in how approaching the problem? And the other question is, we had this very great session on analytical flexibility yesterday, and we heard about the directions of the research and what could be the solution in a few years or sooner. What advice can you give now?
Sure, thanks for that. So I can't say it was a big priority when I was in industry 10 years ago at GSK. I mean, obviously we didn't try to do irreproducible things, but it wasn't, wasn't a focus of interest. Now working with Novartis, they're keen. In fact, actually, I don't know if it's a regulatory thing or it's just a decision they made inside the company, but they need to have any data that appears in a published article has to be available and centrally stored, and ideally there are notebooks that generate the results. So my N of one with one company is that they are taking reproducibility seriously, and it's important. As for yesterday, I really enjoyed that. It was fun, and thanks for everyone who had questions and comments, because I think analytical variability is real. We're all aware of it, but I think the right way is looking at multiverse approaches, and of course, we're working on a grant to do this very thing, which is to say, it is not going to be practical for everyone to do like thousands of variants or hundreds of variants of their analyses, but the people working in this area are trying to figure out, try to do that once or twice, or some limited number of times, to then find which are the most important modes of variation, so that we can then maybe routinely just do 2 or 3 or 4 or 5 or something versions to then and have that as a representation of what we would have gotten if we'd done a much larger. So I think that's where we're going for. It's a frustrating answer if you're trying to say, I want to get a handle on it now, but I think right now we don't have that answer, and the best thing we can do is just the usual good practices, which is, well, if you pre-register if possible, but even if you don't pre-register, just, decide in advance what your pipeline is going to be. Minimize the analytical flexibility that you're giving yourself as much as possible, or use some other data to, to test things around, find the best settings, and that before you actually fix that, and then use that for the actual data analysis that you care about. I think that's where we are.
Steph, if you want to ask the question.
Yeah, to follow up on, we were talking, oh, I'm hearing the echo now too. Are you guys hearing it in the room, or is it good? Okay, that's fine. To follow up on some of the earlier questions about, open data and, you know, collaboration across multiple centers in terms of sharing. We've talked in the open science room about some of these ideas that involve a lot more collaboration across the community and less focus at the individual level, and moving quickly towards producing products. And I'm wondering whether you have thoughts about ways that you think might be most promising for incentivizing these things, which are very much at odds with the current incentive structure in academia. There have been, I think, a few different
Incentivizing
proposals, but
reproducibility.
incentivizing, kind of taking a step back, moving towards collaborating, maybe publishing more slowly, sharing data, and not necessarily, collecting a small data set and just going from there and trying to,
Yeah.
keep it all to yourself, publish yourself, that sort of thing, incentivizing more of
This
this
is
collaborative.
Yeah, no, this is incredibly important, and I don't know I have great solutions to this because there was a time in the early noughts, you might say, if you're in cognitive psychology, your thesis would have 3 experiments, and they'd each have like 12 subjects, maybe 20 if you're ambitious. You get those 3 done, and then, that's your thesis, and, that isn't really going to work anymore. So I think there needs to be a new attitude towards working and contributing towards a large shared open repository, but adjusting that to the realities. I think one thing that could be an improvement is if, this sounds like a pipe dream, but if institutions realize that there are going to be roles that will not necessarily be measurable, the output will not be measurable with the usual papers at the usual pace, maybe like once a year or every other year. And they need to fund these positions to support the work of other people who will then, do the research based on that, based on the data. On the Novartis project that I'm involved in, we have dedicated people called data wranglers. And their role is just to take and harmonize the data and make it, now a lot of this is tabular data, not the imaging data, but just take that data and make it and get it into a research-ready form so that people doing statistical analyses can spend their time on model building. And I think we need to think about that, how, we need people who are going to focus on that, because it is very time intensive and really has nothing to do with cognitive psychology, even though probably we've all done that, if you're a psychologist. And then in terms of incentives, I guess also looking at other non-traditional outputs, of course, the Aperture, that's OHBM's journal, but of course we don't like to call it a journal because it's actually a platform. We're really encouraging people to see it as a place where you can get a descriptor of a notebook or a data set. And of course there's places like Scientific Data, which are all about sort of recording a shared data resource. So I think those are some of the way forwards, but it's, it's a changing platform, and I feel like the institutions are not ahead of this. I don't know. Maybe someone could tell me differently, but I'm a little bit worried on that end.
It's really neat to hear you talk about your experience with industry. You're talking about like these built-in platforms for ensuring that data can be found centrally and reproduced using like within company notebooks. And we're also talking about having dedicated data analysts, which is like not a new thing in industry, but for a grant, like it's still very hard to hire like a dedicated software engineer and pay, comparable to what an industry position could pay them. So it's really interesting to hear all these different ways that industry might be outdoing academia in terms of reproducibility, all these little elements that contribute to reproducibility. On perhaps the flip side, I wonder, oh yeah, go ahead. You had thoughts about that.
Room.
Yeah.
Hi, I'm Niamh. I just had a question. So I think it's really interesting that we're kind of seeing this increase kind of discourse between like industry and academia, but I often wonder like one of the kind of key agents that might be missing from this conversation is like the public as like consumers of the research that we produce, and like whether or not we need to expand the conversation about open science to the public, especially with the rise of misinformation and anti-intellectualism. Like you can see that a lot from COVID. There's like spread of so much misinformation online, and there's a lot of kind of criticism of, for example, like pharmaceutical companies not making their raw data openly accessible. And I don't know, I think sometimes it seems to me anyway that, you know, how are we going to address that as a field to try and include the public in that conversation to kind of fight back against the kind of anti-intellectualism and misinformation. So I just kind of be interested to hear your thoughts on that.
Well, I certainly think, you know, the public doesn't care and probably doesn't want the raw data. That's for us, right?
Yeah.
But I do agree that we need to up our game on sort of public outreach, and I'm very proud to be associated with WIN, who takes this very seriously. And I don't know if anyone's here with them, but they have a whole committee on how we're going to do outreach. So a lot of it's you know, going to schools and stuff, but some of it's like, you know, doing pub talks and the like. And I think that's something that we should take seriously. I also know I'm forgetting which part, what project it is at Oxford, but where there's a serious component about with clinical stuff, reaching out to the patients and actually letting them know what's going on and letting them know how this work will benefit them, and having patient representatives on certain panels. So I think it's underappreciated, but I think hopefully that we're moving in that direction.
Okay, thanks.
And we have another question in the room. Al May, who I worked with at GlaxoSmithKline, he can contradict everything I said if you want.
I was reminded of a BIDS discussion where I was 2 days ago, and somebody said, let's start the discussion with a controversial question. So maybe this is a bit controversial enough. Do you think that OHBM should play a role in the open science and the open data community? And I'm not saying that we don't at the moment, but
a massive role, I would say.
By having a platform for sharing stuff like data, would that be desirable even?
Yeah, I think we have lots of ways of sharing data, and there's lots of people involved in OHBM, meaning researchers who are doing that. You know, especially in Canada, there are all various sort of data repositories that are there, CBrain, Loris, and such. So I don't think you know, there's limited resources of the organization, and I don't think that's something that is probably the best use of it. I think Aperture is, I think, a good sweet spot of like, we will have, you know, their PDF entities that describe, you know, objects, and I think that's probably the right use.
The right level.
Yeah, right level.
Yeah, okay. Yeah, I sometimes get the feeling that when you apply for grants, people can't get money to get access to data or something, or can't get or forget to do it, and then don't have data. And I think maybe it's just
It's changing. I mean, I think in the Netherlands there's a focus on data sharing, and certainly in the U.S., NIH is basically mandating it. It used to be like only grants bigger than this, or this exception, that exception, and now I think that's all going away. Like, if you have money from the NIH, you must share your data. So.
Yeah, but it's definitely good to point people in the right direction, I think, and with the advent of machine learning and deep learning and things that require massive computers, it's probably the same thing, right? It's access to data and access to tools, probably.
Yeah. You know, we should, and also I thought about it yesterday. I think someone was asked a question about all the pipelines. You know, we should be mindful of that. All these variants are going to, you know, consume electricity, which is, you know, that has a carbon footprint. So. And we're doing it for a good reason, but we should be mindful about that, and it's yet another motivation to figure out how few, you know, after we've done the initial work, figure out how few pipelines we can get by with.
I like that. Yeah, a morality to not overuse, for example, deep learning.
Yeah.
Another controversial idea.
Mm-hmm. We have another question here. Is that Lars?
I have a quick question, more as an observer. I've seen the debate being paraphrased about reproducibility.
That's a hard word, yeah, I know.
Is a terminology that's related to hypothesis testing, whereas evidence accumulation innovation framework does not have this kind of problem. And I would like to take the opportunity to get your view on this.
So the role of hypothesis testing in generalizability as opposed to just accruing evidence.
Yeah,
And it's in a
accumulating
Bayesian
evidence.
framework.
So the idea is in the Bayesian framework, you mentioned earlier small size studies, would still be a contribution to the evidence accumulation. They serve a certain purpose. You have a certain hypothesis. You acquire, more evidence, and that's basically, fair thing to do. It's not so much the question whether you have a predefined hypothesis that you need to test at a certain p-value. But I'm just observing, so I don't have any stakes.
So I mean, I like Bayes, and I think there's definitely a role for using prior information with small studies, and I think that's a very important direction. And I've seen some posters on that kind of direction, and it has different names and transfer learning and the like. I think the only limitation is you have to be very transparent about what is the prior information going in, and if you're making some conclusion on those 20 subjects, I mean, by definition, you're borrowing strength from the previous information, but does that limit the value of the answer? Or does someone say, well, that was in the prior, so what have you really learned? So, but in general, I would say that's why it is so important to share the data and share the results, the statistic maps, so that other people can do meta-analyses, another thing I'm interested in, to help see what generalizes.
Great, thanks.
I have another question in the room here.
Hello. Hello.
What's your name?
Arun. So I have a couple comments, questions type things. Number one, I work with samples of neonates or infants, and so we work with parent interest groups. And I mean, they tend, there's obviously a process of education from both sides because we have very different perspectives. But they can, over time, they have questions that usually, lead to new scientific questions or perspectives on what you're doing. But also, they're very influential in terms of policy development as well as when you're interacting with clinicians because they'll more likely
the parent groups.
The parent interest group, they tend, some of them are extremely active, and so they tend to have quite a bit of influence, both, with politicians. Politicians will always listen to parents, as well as with clinicians. I've had clinicians tell me, what has neuroimaging contributed? So again, they're very skeptical, but it's a way to, you need to get all these different groups together. And that's, the parent interest group I've found is a really good avenue. You need to work together, but it's something that, I would encourage people to do. And the other thing is just, I've thought that, these open science databases, resources that are available, in some way also support, academic freedom at universities because you have resources that are, quote unquote, freely available and may support you in doing your own curiosity-driven research and not have perhaps to follow.
Sure. I mean, just look at the impact of the HCP, UK Biobank. They're on like every other poster here. They're really,
So,
good comments.
Yeah.
Thanks.
Thank you.
Have we another question in the room?
Hi, my name is Yannick. I was wondering if you have any advice on how to make a convincing case for if you have null findings, neuroimaging null findings, I want to publish them because I find it really hard. Many people don't believe it out of several reasons, and of course there are a lot of reasons why you don't find an effect, even if an effect is there. So I was wondering if you have any recommendations for that, how to really make a convincing case.
And it in some ways it's really unfair, right? That if you get a positive finding, everyone's like, okay, woo, woo, and then if it's a negative finding, well, how are you really sure, what's your power? So that's unfortunate. And all I can say is that, yeah, it is harder to get that stuff published. I mean, I've heard, journals say, no, we want to have more, we're more receptive, but, I think proof is in the pudding. I think all I can say is that you just need to, it's the one place where you can actually do phishing, right? Because normally we obsess about controlling false positives, but if you're trying to show that something isn't there, it actually says, okay, well, I can try to analyze it this way, analyze it this way, analyze it this way. And when they're all coming up negative, that's compelling evidence, or giving false positive rates, giving positive that's consistent with a nominal false positive rate, that adds to the evidence. So that's one thing you can do. And again, it's usually you can't, but it's the one place where you can do that. But it's hard, yeah.
In my experience, if that's consistent and you have a consistent null finding, that's an easy case. But if you have then one or two ways of analyzing
Welcome
it,
to the
and there's
multiverse.
a different result, and then you can't really say anything.
I know.
That just makes it so hard.
I know, and it's really unfair because we, obviously we should be as skeptical, with positive results, but there's that extra level that's required with negative results. Yeah.
All right, thank you.
And we got another question.
So we're getting close to time, but I think we have time for just one more question.
Okay.
Thank you all for your great questions.
Hi, I wondered if you could
What's your name?
comment. My name's Megan Robinson. I wondered if you can comment on, kind of to build on the last point, that it's so much easier to publish a positive finding, and then there's this push. There's it's kind of a blanket statement that if we want reproducible science, we should open up our data for other people to replicate our findings. But what's stopping there from being an abundance of people that perhaps have more time than they have integrity, and just downloading 16 different data sets, trying each one to find their pet hypothesis, which then they can publish, even though they had null findings in the other 15, or I guess maybe a good number is 20. If you download 20 data sets and try the same hypothesis 20 times, you should find a positive result in one. And then you can publish that. And then you have the backing, potentially, of say, well, I found this in an HCP data set. So we know it's a good data set. We know there are 1,200 subjects behind it. And if you have 1,200 subjects, but it's downloaded by many thousands of researchers, each doing their own analysis, where's the correction for those false positives on the data set?
Yeah. Well, so the first part is that that's just a fundamental aspect of scientific integrity that you should disclose when you do a body of work. What are all the different things that you consider? But it is true. I mean, that's how a career evolves. It would be idiotic to control your lifetime false positive rate over all things, and we consider kind of each research output as kind of a standalone thing. But yeah, I think we have to be aware of what's going on with the HCP. It will be the same thing in the UK Biobank, that there are lots of different things, and I think it just comes with any kind of scientific criticism when you look at something like how plausible is this? Extraordinary claims require extraordinary evidence is the kind of thing. But yeah, I don't know. There are techniques. There's someone out there who's proposed methods of alpha spending, which actually would partition false positive rate over a lifetime of a project, and it goes down the more people that use it. But I just don't think it's practical. It requires a level of coordination that I don't think will ever be possible, and I'm not sure it's the right thing. So I think we have to use general non-statistical reason and sort of skepticism, and I think that's the best tool we have for us right now.
Thanks.
All right. Well, thank you all for your wonderful questions. I just want to add, I see JB in the chat regarding the last point, was mentioning that you can only interpret null results. He was arguing that you could only interpret null results if you have sufficient power in the first place. And JB, we could welcome you. Actually, I think we do have to wrap up, but that would be an interesting point to follow up on. Yeah, we're already a couple minutes over. I'm not sure when the next session is starting, Naomi. We could have Tom, if you're available, you could stick around in case people wanted to come up to you for a minute afterwards and say hi. But I think we'll have to perhaps wrap up on the virtual side.
Yeah, our next session is in 13 minutes, and it's our closing ceremony, which is virtual now. So if you want to join, there's a link on our website.
Okay, thanks for coming, everyone.
Thank you.